Hey, how do you know which one it is?
Well, Mr. Fine, it's the vertex.
Right? That's what I'm saying.
You're going to be doing your little work, la da 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 da. You got your X, your Y, X, Y, la da 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 da. And all of a sudden you're going to get something weird like this: 0 equals 0. What's funny? Oh, good. Okay, so 0 equals 0, a little weird. Or you're going to do your math and you're going to get like 0 equals 4. That means you didn't do something wrong, but you got to go and have a closer look, because you might not have any solutions, or you might have so many solutions you can't write them all. So let's just talk about exactly what we're looking at. Well, we're looking at three different scenarios. The first scenario is right here, the normal case. With the normal case, you have two different lines. And so they're only going to cross once. All lines that will only cross once. You only have one solution. And that's all we've had so far. We'll have an x value, a comma, and a y value. And we'll be smart enough to put it in brackets so you don't lose marks. Wake up, Kyle. Okay, so strategy. What do we have to have two different lines? In order to have one solution, the only thing we need is to have different slopes. That's it. If we have different slopes, automatically there's absolutely no way to have our lines cross more than once. They have to cross once. We don't know where, but they will only cross once. The intercepts are kind of irrelevant. The intercepts could be the same, or they could be different. We don't really care about them. But if they are the same, then guess what? This would actually be where they cross. Doesn't matter at all if you know that or not. Okay, I just want to point that out. That's a little bit different than our other scenarios. What kind of lines do we have down here? Parallel. Okay. Parallel lines. And the thing that makes them parallel is that they never cross. So how many solutions would they have? Yeah, 0 solutions. Or sometimes you will just say no solutions. Whoops, S-O-L. Ooh. And sometimes you'll just write null set, which means no solution. Okay. So it's kind of, 1, 2, 3 different possible ways of saying the same thing. Okay. Vocab-wise, get to know them all. What makes them parallel, though? Why are they running side by side? Same slope. Okay. That's really, really important. Same slope. What about their intercepts? Yeah, they have to be. Because if they weren't different, then you'd have the exact same line. So we must have the same slope, and we must have different intercepts. Okay. So below, we have a situation where the intercepts are exactly the same. We have what we call the same line, and that's not math speak. We gotta make it hard. We'll call that the coincident line, or coincident lines, sorry. Okay. So we got, normal talk, same lines, and math speak, coincident lines. Here, we would have many solutions. Or so many that there would be infinite number of solutions. And sometimes we use the infinite symbol. Oops, infinite solutions. Please write solutions 3 times, because the answer infinity is not correct. Infinity is a number or an idea And that's not the answer. The answer is infinite solutions. Okay, so be careful with that. There's a bit of a difference there. And what two things must we have to have the exact same line? That's right. Same slope, same intercept. Now we do have to be careful because we're not going to be that easy on you and just say, oh, here's the exact same thing. We're going to write equivalent equations like we saw yesterday, where they'll look really different, but they'll be exactly the same thing. Okay. The idea is to change it into y equals mx plus b, and then you can look at your slope and your intercept to decide which scenario fits. And so that's exactly what we're going to do here. It doesn't say to solve. No, it doesn't say that. It says to determine the number of solutions. So let's take this one and turn it into y equals mx plus b. And then we'll take this one and work down and turn it into y equals mx plus b. So I'm going to show a lot of work with the first one. And then if you know what you're doing, don't watch. You can go ahead. Otherwise, we're going to go minus 6x both sides. And we'll get negative 4y. That cannot change. And that equals negative 6x. The 8 is positive, so we change the positive sign to plus. The next step is we divide both sides by negative 4. And so we're left with y equals negative 6x. And it's negative 6 divided by negative 4 plus 8 divided by negative 4. So negative 4 divides both terms on the right side, all of it. Now we must simplify. So 6 over 4, two negative signs become a positive. Divide by 2 to put 3 over 2 as the lowest terms. 8 divided by negative 4 is negative 2. Okay, so there's step by step how to think about changing it into y equals mx plus b. Okay, go ahead and do the other one now. Do the bottom one if you haven't done so. Okay, I'll give you a few minutes. So what we notice at the end is these very different lines at the beginning are exactly the same. So what's the answer to the question? Determine the number of solutions. What are we going to write down? How much? 1? Look at your slopes. Look at your intercepts. Same. So we'll say many or infinite solutions, your choice. Because we have the same, because the same line, because they have same slope, same intercept. Okay, so many solutions because of the same lines. I guess I should say lines with an S. And that's because of the same slope and same intercept. Any questions about this? Could we tell at the beginning exactly that they're the same? No, you got to do a little bit of work first, okay? Where you can hide these things pretty easily. Turn it over for number 2. The good thing is, different question, but exactly the same way to solve it. Turn this into y equals mx plus b, and the other one as well. Okay, y equals mx plus b. Then it's easy to look at the slope and the intercepts. Okay, go. Okay, so I got the first one done. I showed lots of work. Please check yours. Okay, so looking at those two equations, what have you got? Same slope, different intercept. So those lines are parallel. And how many solutions for parallel lines? 0 solutions, because lines, oops, that's weird. Lines are parallel. And the reason why they're parallel is that you have the same slope and different intercepts. Okay. So you need to really explain in detail why there are 0 solutions. 0 solutions will not be a lot of marks. Right, Sabrina? If they're still there, tell them to leave. Okay, all 3 questions were y equals mx plus b. Yeah, well, considering how little work you've done. Y1 solution. That's right. One solution because they're different lines with different slopes. We do not need to talk about the intercept. The intercept is irrelevant. It has nothing to do whether the lines cross where the, okay? It's the slope that matters. So let's have a quick look down below here at this next question. Or so before I go on, any questions about this one? Any of them? So what are you going to have to do today? Change your equations into y equals mx plus b. So this last one, we'll just kind of summarize everything that we've done so far. Here's this crazy equation. We want to then write 3 separate equations. The first one with infinite many solutions. What kind of lines have infinitely many solutions? Same line, so we want to have the same slope, same intercepts. Intercept. So we don't want to change anything. What could we do to make an equation like that? Take this equation and do what? Times it, right? Times it all by a common number. What would make sense? What kind of number would be good? 6. And why? Because of the 3 and the 2. So we're going to multiply it by 6. We're going to take 1/3 x plus 1/2 y equals 8. And you can multiply it all by 6 by doing this, or multiply it individually. So the individual multiplication will be times 6, times 6, times 6. And make sure you divide first. Okay, so divide your fractions, the new denominators. And you should get 2x plus 3y equals 48. Okay. What about no solutions? What kind of lines would have no solutions? Same slope, different intercept. Now what's unique is that the y value is part of your slope, but it's also part of your intercept. It can't change. The 2 is part of your slope. It can't change. What's the only number that can change? 48. So for no solutions, we should have 2x plus 3y, but you can pick any number for that. Any number. So I'm going to choose just here. Pick a number, any number. 4. There you go. So this could be any number you want. Okay. Now you could still write it as 1/3 x plus 1/2 y equals 4. That's fine too. You don't have to have this 2x and 3y.
Dog ate it.
Okay, this last one. Sorry, this last one here, one solution, super easy. Guess what? All you got to change is your x or y. So we can just go 3x plus 3y equals 48. That works. Another number. 2x plus 12y equals 48. The 48 can change, but an x or a y must change. You can even go 1/4 x plus 1/2 y equals 8. As long as you got a little bit of a change on your x or your y. Yeah, you can totally change every single number you wanted. Doesn't matter. Okay, easy question. Emma, done? Question? No? Okay. We need to add, why do we change the x or the y? What do we need here? We need to have a different slope. Okay, so please write that down. That's kind of important to know why we're changing x or y. And it's just to get a different slope. Okay? So make sure you write down different slope as the reason for changing x or y. That's kind of an important thing I forgot to write down. Okay? Okay, put up your blind.